Okay, next question, 23. Question number 23. This one, page 170, I think still now. Let me read once. One electric heater is rated 1500 watt. How much energy does it use in 10 hours? So, since the electric heater is rated 1500 watt, therefore energy used by this heater in 10 hours denoted by E. We know that P is equal to E by T. So we know E by simple understanding also T will go up. So P into T. Right? So once we are through with that, power is, what is the unit of power? So power is 1500 watt is the power of the heater. Time it is switched on is 10 hours. So T is the 10 hour. You can just put H also if you want, or HR, up to you. So they'll give you nothing but these two multiplied will give you 15,000 watt hour. But energy consumed is usually calculated in commercial unit, that is kWh. So let's change this W to kW. So how do we do that? We know here that 1 kW means kilowatt is 1000 watt. The word K means kilo, which means simply 1000. So changing watt to kilowatt means smaller to bigger, so we have to divide by this 1000. Then this W will change to kW. This H will remain same. So that way you're going to get these 3 zeros cancelled, and you're going to get in 10 hours this electric heater is consuming 15 units or 15 kilowatt hour. So this is our answer. Okay, I hope you got it. One more question before we end this portion of test 26. So go there now. Question number 26. I think it's on page 172 if I'm not wrong. 71, sorry. Yes, so calculate the work required to be done to stop a car 1500 kg moving with a velocity of 60 km per hour. So this car is moving and you need to stop it with a force, most probably by application of brakes. So how much force should be applied on the brakes to stop this car? Okay, so the picture is that of what I said just now. Force required to stop the car. So as we read the question, we get here M 1500 kg is the mass of the moving car. That's obvious. V, velocity with which it was moving, is 60 km per hour. So we need to change this one to SI unit. SI unit of velocity is meter per second. So in order to do that, we know that we need to know this thoroughly. Conversion units for length, kilometer or distance, hectometer, decameter, meter, decimeter, centimeter and millimeter, which means you need to change from here to here, kilometer to meter, moving 1, 2, 3 place. So big to small, so this kilometer change to meter means 3 more zeros multiplied, then divided by, nothing is here, means 1 hour. So if you want to change hour to second, we know hour, minute and second. So here second, then you're shifting 2 places to the right. So 1 place shift is from here to here 60 minutes, then another 60 second, 60, 2 places. Then this kilometer has changed to meter because of these 3 zeros. This hour to the power -1 is changed, second to the power -1 because of multiplying this 260 here. That way we get these 2 zeros cancelled, and 6 ones are 600, 2 3s are 6. So this is in SI unit 50 divided by 3 meter per second. Since the car is moving, since the car is moving. Clearly the question says that. Therefore its kinetic energy Ke, which is denoted by Ek in your textbook. For initial kinetic energy, let us write here Eki, okay, is equal to, now initially, okay, initial, this, let's put it, this is also okay, but initial U, okay, the half mu square, half into mass is 1500 kg, as you can clearly see here. U is 50 by 3, so U square will be 50 by 3 into 50 by 3, and this one squared, so meter square, and second to the power minus 2. So this way we can now cancel here. I think this will go away. 2 7s are 14, 1 in hand, 5s are 10, 0. Just shift this little bit, half. Okay, 750. Then 3 2s are 6, 1 in hand, 3 5s are 15, 0. I think that much only. So 5 5s are 25, 25 and 25, 625. So let's write that 625 for this part. 25, 5 5s are 25, 25 into 25, 1 2 3 0. So 1 2 3 0 divided by, here is set 3 here. Just keep it like that. Then this is nothing but kg. This meter square, just double it, meter meter, kg meter per this one second square into, and 1 meter. Let us put it back. So as we go on here, they'll give you equal to divide it now. 3 2s are 6, and 2 is less than 3 means 0. 3 8s are 24, 1 in hand, 10. 3s are 9, 1 in hand, 10. 3 3s are 9, 3 3s are 9, up to here. Point, then 10, 3 3s are 9, 3 3s are 9. It will keep on going. So this is going to give you kg meter per second square is Newton, and here meter. So this will be nothing but 208,333.3. Second place less than 5, so this will remain same, joules. This is the initial kinetic energy of the car when it is moving with initial high velocity of 60 or 50 by 3 meter per second or 60 km per hour. Now the final, you need to find out E, let's write down here, final kinetic energy, that is EKF, let us say, be 0 joules. Since, if you want to give the reason, since it comes to stoppage. Stoppage means not moving anymore. So clearly the textbook says this car needs to be stopped. It means the final velocity is 0. So since it comes to stoppage, so it will be, I can show if you want, final. Okay, just 1 second then. Now V will be 0 meter per second. Write that down. Final velocity, since it comes to stoppage or rest. So if you stop, velocity is not there, so 0. Therefore, final kinetic energy EKF will be half mv square. So half into 1500 kg into V is 0, so 0 meter per second, whole thing square, V square. So there will be 0 means everything will become 0, so 0 joules. Okay, so that is the one. Now finally, write down work required to be done. Go back to question. Work required to be done. So work done to stop the car means the force or the work done is final kinetic energy EKF minus initial kinetic energy EKI. Final is 0 joules minus initial is 208,333.3 joules. So it will be minus 208,333.3 joules, which is nothing but negative. A little bit of explanation, which is negative. So just write that down, which is negative. So that means work done is, and simply write the answer. Work done is to stop the car, that is 208,333.3 joules, comma. Okay, and negative means, and force X, and the force with which the work is done, force X opposite to the direction, okay, direction of motion of the car. That means the force applied by the brake will be acting opposite to the movement of the car to stop it, right? Direction, the negative clearly indicates that. So direction of the motion of the car. So that's our answer. I hope you got it right. So now you can go. All the questions are completed. Give the test 11E. Okay.